So in today's video, we are going to do a quick review of inverse functions. So the first type of problem we're going to look at is when we're asked to find the inverse of each of these equations. So the first thing we need to do is replace f of x with y because we know they're the same thing. And then we're going to switch the x and our y in our equation. After we do that, our whole goal is to solve for y, no matter what the equation is. So to get y by itself here, add 7 to both sides. And then we're going to divide by -5. And we can just leave this as a fraction. I'm not asking you to separate it any specific way here. And then we want to make sure to use our inverse notation to write what it's equal to, which in this case is f (-1) of x. So that would be the inverse of the first one. So same thing with the next one. We are going to replace f of x with y. Then we're going to switch the x and the y. And then we're going to solve to get y by itself. So to get y by itself here, first thing we're going to do is subtract 10 on both sides. Then I'm going to multiply both sides by 8 to get the 8 out of the denominator. And I have to distribute the 8 to everything over here. So that gives me 8x minus 80 equals -5y. And then again, I'm going to divide everything by -5. And then I'm going to, since that cancels out here, and I know I just have y left, I'm going to write my inverse notation. Okay, so that's what it can look like with a linear expression or one that's just a line when we graph it. But looking at maybe a quadratic or a cube, we're going to follow the same process. So we replace f of x with y. And then we're going to switch x and y. Now, again, I just want to solve for y. So first thing, to get y by itself, I'm going to add 3 to both sides. So I get x plus 3 equals y plus 2. To get rid of the square root, I'm going to square both sides. So when I square the left side, I have to make sure that I'm multiplying binomial times a binomial. So I'm going to use a box. So x times x, x squared, x times 3, 3x, x times 3, 3x, 3 times 3 is 9. And then we see these two like terms that we can combine. And then on this side, the square and the square root just cancel out. So I get y plus 2. Last thing, to get y by itself, I'm going to subtract 2 from both sides. Plus 7 equals y. Then I can write it with my inverse notation. Perfect. So let's look at number 4. Same thing. F of x is y. Then we're going to switch x and y. And then work on getting y by itself. So add 2 to both sides. X plus 2 equals y plus 4 to the third. To get rid of a cube, remember we take the cube root of both sides. So cube root of x plus 2 is equal to y plus 4. And then to get the y by itself, we subtract 4 from both sides. And then finally, we're going to write our inverse notation. There we go. So that's what it's like when we're asked to find inverses. If we are asked to determine if two functions are inverses, we're going to use these two kind of rules right here. So we're going to take f of g of x, and if that equals x, we continue going. And then we're going to do g of f of x, and if that continues x, with both of those things being true, then we could say that these two functions are inverses of one another. So first, I'm going to start by doing f of g of x, which means I'm going to take my f function. Everywhere I see an x, I leave a space, and then I'm going to put my g function inside of it. And then I'm going to simplify. So the 5's cancel out. I have x minus 2 plus 2. 2's cancel out, and I'm left with x. So that's a good place to start. And then I'm going to do the same thing, but the other way around. So I start with my g function. Everywhere I see an x, I replace it with f of x. And then I simplify. So since I don't have anything outside the fraction, I'm going to simplify my numerator first. So plus 2 and minus 2 cancel. And I have 5x divided by 5, which is x. So since these conditions are both true, then they are inverses of one another. Okay? And no matter what the functions are, that's the way that we are always going to check them. So again, on this next one, I'm going to do f of g of x. I'm going to plug in, see how it goes. So everywhere that there's an x inside my f function, I'm going to leave a parentheses, and then I'm going to put my g function inside of it. Okay, the fifth root and to the fifth power cancel out. So I have 7x minus 2 plus 2 over 7. The minus 2 and plus 2 cancel. So I have 7x divided by 7, which is just x. And then I'm going to go the other way. So g of f of x. So everywhere, I'm going to write my g function. Everywhere I see an x, I replace it with f of x. The 7's cancel. So I have plus 2 and minus 2 that now cancel. And then the fifth root of x to the fifth cancels, and I get x. So again, these two are inverses. If for some reason one of them did not equal x, maybe one did and one didn't, or neither of them did, then this would not be a function, or they would not be inverses of each other no matter what. Both conditions have to be met, or they have to be equal to x. Okay? Now, we need to graph the inverse of the function below. So, first, we're going to start by finding some points that are nicely on our line. So, I'm going to do those in blue. So, the first point I found was negative 2, 4. Then I had 0, 3, 2, 2, and 4, 1. Now, when we want points of the inverse, we're literally just going to switch the x and the y. So, negative 2, 4 becomes 4, negative 2. 0, 3 becomes 3, 0. The next one stays the same at 2, 2. And then we switch it to 1, 4. So when I put those new points on here, go over to 4, down to negative 2, over to 3, 0, 2, 2 stays the same, and then over to 1, up to 4. So we should get the same type of shape of our line, it's just going to be oriented in a different direction. So this one takes a steeper slope when we switch it. So you can do that with any shape, no matter what it is. Find 3 or 4 points, and then you're going to switch the x and y value to get the new points.